Pat Bartlett is a geologist, come mining engineer, dual qualified. He's been 57 years in the diamond industry, having started work with De Beers in 1965, I presume as a field assistant or field officer before he graduated. He has qualifications from Rhodes University in geology, a MSc from London University, and a PhD in mining engineering from the University of Pretoria. He has various other non-technical qualifications that are listed in the abstract volume from other institutions. He's worked for De Beers on the West Coast mines, Chuaning in the early days of the evaluation, on the various Kimberley mines, and he spent a large part of his career at Cullinan Mine, close to Pretoria. He's been a board member for Rockwell Diamonds, Petra Diamonds, and is currently an external consultant doing work on project development with a number of major mining companies. Pat is going to talk to us today about diamond mining methods applied to kimberlites and lamproites. Pat, over to you.
An overview of the contents on what I'm talking about. So first of all, have a look at a typical kimberlite pipe, because the mining method that is used on the mines is really determined by the shape and size of the ore body, and also by the dollar per ton of the ore in the ground. So most kimberlite pipes are pretty much carrot-shaped volcanic pipes, and the logic of mining the pipes is therefore pretty similar. And the second major item that I'm looking at is typical kimberlite and lamproite mine, the technical and financial evaluation, the steps that you would go through. And then looking at major diamond pipes worldwide, looking in South Africa, and really because I've got the best information there, looking at some depleted mines, Bultfontein as an example, looking at a mature mine which has been going for a long time, Cullinan, and then looking at Venetia, which is currently, well, it's almost ready to start producing from underground. So they're transitioning from the open pit to underground, and then a major mine that's planning to go underground, Chuaning. Then I look at some of the Russian operations and then other diamond pipes throughout the world, the main ones, and then some observations that I'm just making and some risks. I think it's important just to emphasize again that I'm just talking about kimberlite pipes. I'm not talking about the alluvial deposits or anything like that, because they add another dimension to it. But this is obviously just a model of a kimberlite pipe. So it's a carrot-shaped ore body going down. I think most of you have seen some version of this or the other. And as far as the mining method goes, right at the top of the pipe, you normally have, in the old days, it was a glory hole. I'll show you what I mean by a glory hole. And these days, almost all the major mines will start as an open pit. So near surface, kimberlite to a depth of 70 meters, sometimes a lot more than that, can be in clay-rich, soft yellow ground that historically was mined with a pick and shovel. These days, if you find something like that, you can mine it with a big loader. As they went deeper, you started to run into various problems. And in the old days, they used a mining method called chambering, which is very much like block caving in principle, but they didn't have the technology and it wasn't a very safe method. And so as the kimberlite ore becomes more competent below the zone of surface weathering, drill and blast methods are used, or in Russia, in some of those very valuable mines, they actually use road headers. So Mir International and ACOL all use road headers for mining. And as you get deeper and the shape of the ore body becomes complex, the size decreases, and that can constrain you from using various caving methods. And it might not be practical to use block caving. You might have to move to sub-level caving or some other version of underground mining. And some kimberlites are simply too small to allow block caving, and sub-level mining methods such as sub-level retreat are used below some of the open pits. That's typical on some of the Canadian mines. So just a brief look at what I'm talking about. You mine the pipes, typical kimberlite and lamproite mine, technical and the financial evaluation. Starts off with a glory hole, and these days a benched open pit. The edges of the open pits are usually mined using blast hole open stoping, and below that you can use block caving or sublevel caving. And then also just a brief look at how the mines are financed, what the money side of it looks like. But typically, you've got an open pit, initially very little mining of the surrounding rock. So you've got dumps and an existing pit. And with time, the pit goes deeper, and you need to put in the underground infrastructure that you're going to need to mine underground. And that typically will be a block cave, or it will be a sub-level cave. And this is switched around in some mines. Finch, for example, went underground using those blast hole open stoping around the edges of the pit up here. And when they went underground, they used block caving, block 4, and below that, Petra's been using sub-level caving. And what I mean by a glory hole is simply when this is Wesselton mine in the Kimberley area. It was found in 1895. And when they first started mining, they simply went into the hole and took the ground out. They didn't take any of the surrounding area. It was only what was in there. What you're looking at here is the geology. So at the top, you've got Karoo sediments, and this is the start of the Ventersdorp lavas sitting down there. Typically, your mine will start as an open pit, and this is just, I've called it NPV, but you can debate that. It's really the area underneath that line is the amount of money, the value that you have in your ore body that is accessed by the open pits. And then as you go underground, what's below the line is the value that you will have in the ground that's available to you. And this is the capital expenditure that you're going to need to spend to get that money out of the ground. So you start off generally putting a whole lot of infrastructure in, so that's quite high cost. And with time that comes down. But as you get to the end of the life of that pit, you start having to spend sometimes major money in creating the underground, and that creates a lot of problems. It very often means that the decision to go underground is delayed as long as possible, and eventually that dies away, or you might decide that you go even deeper, and then you have more capital expenditure there. And all the time you're going to have operating costs. Operating costs in the open pits are quite low, and they're often not that much higher, depending on the mining method that you use underground. If you use block caving, actual cost per ton isn't very different from the open pit. If you use sub-level caving, that's a bit more expensive. And some of the other mining methods are pretty expensive, like those roadheaders, cost you about $300 a ton to mine. This is just a look at Finch mine. Looking at from the top, you can see something of the surround. So they went, I think the bottom of the pit was about 340 meters, and they put in a whole lot of infrastructure to mine the remnants that were left by the pit. They couldn't get all of it out there. And then sitting underneath that, they had a block cave. And what I meant by your open stoping, blast hole open stoping, is on the left here, you have a diagram showing this is where I've got the cursor is the edge of the pipe. So as you get to the bottom of the pipe, you have quite a lot of ore left behind by the mining method. And you obviously want to get that if you possibly can. And most mines these days make a point of getting that. It's a quick way of getting ore, and it's relatively cheap. So these are the rings that people put in there, and by drilling and blasting, they break that ground up, and it's broken here, and then they use what is pretty much like sub-level caving to come in and collect that ore. In a couple of the mines, Finch was one of them, they used remote control loaders to actually get right into that open pit to collect what they could. So that's the first phase. As they transition from the open pit to the underground, they pick up what they can on the side, and by drilling and blasting, they take as much as they can of the remnants against the sidewall there. And when they go underground, certainly the Kimberley mines use block caving. So around the 1950s, they moved away from chambering to block caving using scrapers. If you went across to the United States, had a look what they were doing in the iron ore mines there, and adopted that method, brought it back to South Africa, and that was implemented fairly quickly on all the kimberlite mines in the Kimberley area. So all that happens here is you put a drill and blast, and you create a void that causes the ground above it to cave, and this can be 100, 200 meters high. And then you start collecting that ground at the bottom here. And rather than using LHDs, it's all scraped. It goes into passes, and then there's a train system down here which takes it back to the shafts or the crushers or whatever. More and more of the mines, they don't use that scraper method anymore. There might be one or two that still, but not many. They use mechanized caving. So instead of having the scrapers, the principles are still the same. You come in on your undercut level by drilling and blasting. You break out a horizontal slice of ore. And if you break out a large enough area, the ore above it starts caving under its own weight. And that broken ore is then collected in the draw points below that using load, haul, and dump vehicles. And some mines don't have sublevel, don't have block caves. They go directly for sublevel caving. There you can see an open pit, and underneath that you've got the infrastructure for sublevel caving. So there'll be, generally it's 4 levels that you're looking at. Or top level, you'll be doing mucking. That's where you've got broken ore, you're taking that to the pass system, taking it down through the crushers, to the stockpile on surface, and through the process plant. You'll often have another level below that where you're busy with charging and blasting, again, just creating ground to take out. Below that, again, you're charging, so you're developing that level, and underneath that, you're starting a new level. So very typically, you'll have 4 levels in production. This mining method works well for, depending a little bit on the quality of your ore, the competence of the ore. It's a bit more expensive. In Finch, it's about 50% more than the cost of block caving. So that's obviously a consideration. This is just an overview of major diamond pipes worldwide. And this is a very arbitrary definition. I've seen a major diamond mine is defined as a diamond pipe mine that has or is likely to produce about $2 billion worth of diamonds or more at current prices over its life of mine. And some of them obviously produce considerably more than that. And what I found quite interesting when I started looking at this, in terms of that definition, and I used that definition because I thought those mines are mines that have been around for a very long time. They've had a major impact, certainly on the regions in which they exist, and very often they've had a major impact on the countries in which they were found. And as I go along, you'll see what I mean. So in terms of this definition, less than 30 major mines worldwide. This is a table. I'm not going to go through all of it. It's just to illustrate some things. So these, what you see here, these red mines, this is the year in which they were discovered, and these were the Kimberley mines. So it's Bultfontein, Du Toitspan, Jagersfontein isn't in Kimberley. It was actually on the way when people were coming to Kimberley. There was Jagersfontein, also the De Beers mine, the Kimberley mine, Wesselton mine. So those mines, they started finding them in 1869. By 1891, they'd find almost all of them. Wesselton was the last one there. Other mines have been found as well. Frank Smith, a small mine. And these are far more recent mines, the Oaks, which was operated by De Beers, you have Fruesbert, and you have Maasfontein. And if you look on this, almost all of those mines are now depleted. And if you look at Bultfontein, it started as a glory hole, and then it went underground. If you look at currently producing mines in terms of that definition, sorry, if I go back to this column here, this is just my estimate of what the value in dollars that was produced by the mine over its lifetime. So if you look at a mine like Bultfontein, it produced for 110 years. There was some downtime there, but it was effectively in operation for 110 years, and it produced $1.8 billion worth of diamonds. If you look at the Kimberley mine, it was in production for 44 years. It produced about $2.9 billion worth of diamonds. And the values and the grades of these things are pretty different. It's very difficult to come up with an average over the life of these mines. So I think my estimates are probably underestimates, but those mines that you see there that now all depleted, they produced about $17 billion worth of diamonds during their lifetime, and obviously depleted. If you look at the current, in terms of my definition, major mines, you have 4 mines in South Africa now. You have Cullinan, Finch, Venetia, and Koffiefontein. Cullinan was also found 1899, Koffiefontein in 1870. And Cullinan has produced about $19 billion worth of diamonds in its lifetime. Finch with a lot, so that Cullinan went for 105 years, started as a glory hole, went underground. Finch has produced about $18 billion worth of diamonds in production for about 58 years, an open pit and then underground. Venetia, about $12 billion, going for about 30 years, still quite a lot to produce. And Koffiefontein, found in 1870, started as a glory hole, went to abandoned for quite a long time, or put on care and maintenance, then as a benched open pit, and now underground. And they produced about $3 billion worth of diamonds. So the value of diamonds coming out of those currently producing mines is about $42 billion. And in total, looking at what the depleted mines, as well as the current mining operations, have produced in total about $59 billion worth of diamonds, which is a considerable amount, especially considering that a lot of this was produced in the early days of South Africa. So it went a long way to funding the infrastructure, the rails, and everything else. It went a long way to financing a lot of the gold mines in South Africa. So these mines have certainly had a major impact and continue to have a big impact on the regions in which they exist. And this is just an illustration of how diamond prices vary. So this is just, diamond is a very volatile commodity, and the variability in diamond prices is high. So this is just taken from a Petra Mines recent trading report. So Cullinan, if you look at the most recent tender, so that that's tender for the end of financial year 2022, the dollar per carat value of diamonds there is $180 a carat. For the period before that, the half year before that, it was $192, and for the year it's $188. That's not much of a variability, but if you look at Finch, their tender force at the end of the year tender, 151, the previous one went to 97. So that's a huge increase for Finch. Koffiefontein, even more dramatic. Their tender 4, most recent tender, $856 a carat. And it was, for the previous quarter, it was $538. Williamson, the same sort of thing. I don't actually know what happened here, but if you look at the most recent offering, it's $369 a carat. And for the last half year before that, it was $760 a carat. So coming up with a figure for what the value of diamonds is problematic. And that's why I say I could well have underestimated what I think these mines have produced during their lifetime. I'm just having a closer look at these depleted mines. And most of them have been depleted after 100 years or so of production. And the example that I had a look at, or that I am having a look at, is Bultfontein. So Bultfontein, this is just a diagram, obviously, of what was there. It was found in 1869, started mining as a glory hole. And then with depth, it went to chambering. And below that, in about 1950s, it went across to block caving. implemented that. It changed to sub-level caving, and then they used a mining method called sub-level crater retreat or vertical crater retreat, and then it went back to block caving. So, and in 2020, eventually it went to a sub-level cave, and in 2020 it closed down. So it had it's 150 years of mining, really, if you look at that thing. Quite amazing, really, that a mine can last for such a long time. This is just not a very good picture, but this is what the mine plan looked like of Bultfontein in 1883. All these tiny little squares, which aren't that clear, are claims in the pit. They're 31 feet by 31 feet. So people had individual claims. By this time, they'd already gone down a bit. So there was a lot of consolidation of the various claims into bigger companies. And this is a photograph. I don't know if it's Bultfontein, I doubt it, but it's a photograph of Kimberley near surface mining operations. So here you can see this is the pipe, and this is access to it, and these were all the claims going down there. It was a real rabbit's warren. And as many as 50,000 people were employed in the mines by 1880. Quite remarkable, a massive rush. And as they went deeper, they implemented these endless rope haulages. So each one of those, it's a winch or whatever you want to call it, will have a rope on it, and the ore will get loaded into a skip of some sort, get taken there, dumped, and so it goes round and round. And in places, they even use these ropes to go down in the skips to work in the morning. And this is just a look today at what Bultfontein, and this is Bultfontein here on the left, looks like. That was about 12 hectares at surface, and this is Bultfontein on that side. And that's the choice plan there. It's got some of the biggest barbel that I've ever seen. They caught barbel there that were about 8 or 9 feet long, massive. And this is the joint shaft that services both of those mines. Petra operated, well, De Beers operated it for a long time, Petra for a short time. And now I think all of those mines are shut after a very long history. This is coming back to Cullinan, used to be called Premier Mine. And it was, they started operations in 1902. And by 1912, when this photograph was taken, you had up to 15,000 people were working on the mine. It never had all the small claims. It was owned by one man, Thomas Cullinan. And the mine operated for 365 days of the year, 24 hours a day. And that went on for a long time. And this is what it looks like today. So you've got a big hole there. It's 450 meters across, 800 meters across in that dimension. And then this is just looking into the pit. You can see some of the old tunnels. And this is just a brief history. It was registered in 1902. De Beers gained controlling interest in 1917. It was closed from 1932 to 45 during the Depression and then the war. They started as an underground mine in 1947. De Beers got the rest of the shares in 1972. They used open stoping, block caving, and then as they went deeper, they changed from scraper caving down to block caving. And there was a big project that was initiated. The plan was to put in a massive cave that would produce at the rate of about 10 million tons a year, but that was, they actually spent a lot of money and they started doing it, but it was never finalized. And the mine was sold to Petra, and Petra came in and they implemented very successfully a block cave, and they've also put in an SLC there. So that's just some of the history of Cullinan. And if you have a look at it from a different perspective, that's your glory hole on that side. So that glory hole went down to a depth of 280 meters, underground from 1947-48. And they operated 8 block caves, 6 open stopes, 1 sub-level caving, and in total there were more than 400 kilometers of tunnels underground. You can see some of that infrastructure. And these are just some famous Cullinan diamonds. The Centenary diamond was found in 1988. It was sold to a consortium fairly soon after it was found for 80 million. And this is a value that you see there, the most recent value that I could find, that it's now been valued at 100 million. It was, when it was cut, it was 206, it was over 600 carats as a rough diamond. The cut diamond was 273. It's the largest, third largest found at Cullinan, considered to be one of the most colorless and flawless diamonds. And it was cut by De Beers with a special cut, computer designed. I think there were 103 or 104 faces. And then this is probably the most famous diamond that came out of Cullinan diamond. It was that you're only really going to know the value of a diamond when somebody pays you for it. But people who've looked at it say that in terms of the market, it should be worth around $400 million. It was 3,106 carats. It's a typical type 2 diamond. It was found in the pit sidewall. So that was one of the reasons people knew from early on that Cullinan produced big diamonds. It was cut into 9 major stones, and 2 of those sit in the royal crown and scepter and crown, and the rest of them were given individually to members of the royal family. This is looking at another mine. It's Venetia. They're actively transitioning to underground. And this is just a view. So you've got the main pipe there, K1, K2, K3, I think that's K3. And there are a couple of other kimberlite pipes there as well. That's what the open pit looks like these days. It's come to the end of its life and they're busy going underground. I think production is scheduled to start from underground in a big way by October of this year. And so this is K1 that you see there. You don't see it very well, but around the corner you've got K2. This is just looking at the plan that they have to mine Venetia underground. So that's the open pit, obviously. These are all the shafts to access the underground. The intention is, because of the awkward shape of the ore body, they couldn't use block caving, and they've used sub-level caving. So this is just the planned cave going down under there, sub-level caving, a huge amount of development. And this is K2. It hasn't been finalized as to whether they'll use block caving or sub-level caving, so it's still work in progress. And I think some of the major advances that you have, you can take your whole mine, so you can design the mine, and once you've designed it and looked at how you're going to mine it and put everything else in there, you can use a numerical stress model of the mining layout. And that's been going now for a while, and they're certainly getting better and better. So use finite element, finite different software, really to look at the stresses. So this is a high stress area. So even though it might not occur immediately, you know that those areas, your tunnels are going to come under high stresses. So you can design accordingly, and you make sure that your shaft system is well away from that. And it's just a great design tool. The other thing that I think is quite recent is they can go underground and they can map the tunnels with LiDAR. And there you can see this is just a typical tunnel underground. And any movement of that tunnel, you can see what's happening. And it literally picks up a couple of millimeters of movement. So it gives you a lot of very early warning of what's going underground. Again, just an innovation that I think is making underground mining a lot better, a lot safer, more predictable than it used to be. This is just looking at the Russian pipes. There were, or historically, there were 3 main regions. So you've got Udakhny, one over there. This is way up in the northern part of Russia. I think the Arctic Circle comes through about there. They have about 6 to 8 weeks of summer. For the rest of it, it's winter. There are no roads. You can't drive from any of those areas to Moscow. You can use the sea sometimes, and otherwise it's all helicopters and fixed-wing aircraft if you want to move around. You've got the Archangel region there as well. And so this is Udachni, number one. Got Eichel, which is another area, and got Myrni. So Myrni is a substantial town these days. Probably 30,000 people stay there. And Eichel and Udachni, probably around 10,000 people. And there's a number of alluvial deposits associated with the various pipes, but I'm not going to talk about that. So again, just a table. I'll point out some of the things. I'm not going to go through the whole table. A lot of the mines were found. The Russians started looking for pipes seriously, for kimberlite pipes seriously after the Second World War. And in a relatively short time, they'd found the Udachni kimberlite cluster, they'd found Eichel, and they'd found the Myrni cluster. And because it was so high grade, the Myrni came into production very quickly. Found in 1955, by 1957, it was in production. The others took a bit longer before they got into production. It's difficult, you can get the grades, it's very difficult to find out what the dollar per carat for is of those. What seems to be a general consensus is that South African diamonds, at one stage anyway, were worth about $100 a carat, and the Russian diamonds at that time anyway were worth about $60 a carat. And these pipes, all the pipes in red were found very quickly in these days. And since then, the Russians have found a number of pipes. Haven't really been able to look at the value of these pipes in the ground, but they've certainly had a major effect. Everybody that stays up there really depends. So the towns of Myrni, Eichel, and Udachni are there because of these mines. Again, they started as open pit. 4 of them are now underground. And you had effectively 12 mines, which I think are major mines. If you look at this is just some pictures of that. That's Eichel, open pit. They're going underground at quite small tonnages. It's only 500,000 tons a year. They've been in production for some time. And this is Udachni. It's certainly a major hole, one of the biggest in the world. The final pit depth is 640 meters. What amazed me is that these faces, most of them are 105 meters high. If you think of an open pit, say here in South Africa, 15 meters is high. There they go to 105 meters. I think the permafrost helps them quite a bit. But here you have the portals allowing them to go underground. So the intention here is to go underground and put in some form of caving in these two lobes that you have down there. Eichel came down with an inclined shaft, and they've used road headers because they're very high grade. So they've used road headers to take that out. The mining cost here, I would guess, probably getting on for $100 a ton. The mining cost here, well over $300 a ton. International is an amazing mine from my point of view. It starts off, it was funnel shaped close to surface, down to about 125 meters. The average grade was 800 carats per 100 tons, high quality stones. So a ton of ore in International is worth about $1,600 a ton. And when they completed that open pit, it took them 19 years to get underground. Every problem that you can think of. They've got the permafrost, obviously, then they had oil, they had gas, they had mining methods, they had all sorts of problems. But it's a mine, it's going, produces good diamonds, and about 500,000 tons a year. And this is just having a look at other kimberlite pipes worldwide. Obviously, Botswana is a major producer of diamonds, probably the biggest producer of diamonds from mining operations. You've got Arapa, which was found in 1967, got the 2 Letlhakane pipes fairly shortly after that. And these mines are all found by Gavin Lamont, together with Tim Gibson. And then fairly shortly after these mines were found, or these pipes were found and brought into production, they moved Gavin Lamont down to Lobatse. and they gave him really a shoestring operation. In no time at all, he picked up another mine, Jordan, massive mine. These are just looking at dollar per carat, about $60, but by the time they finished mining, $21 billion worth of diamonds, if not more. And really, an absolutely amazing mine is Jordan, because the value of the production from there, the open pit is scheduled to run for about 41 years. It probably come to an end in 2032, 34. And then it'll go underground for whatever, 20 years or so, maybe more. They've got good quality diamonds there. The dollar per carat is high, so 130 billion really dwarfs an awful lot of the other production worldwide. Angola, you've got Katoka. Again, it's a very nice operation. You've got Uraxi coming into production. This is small, really. It's only 0.22 of a billion, so it doesn't have a major effect on Zimbabwe. Canada, there are no really big mines, but they're clusters which have certainly been very valuable. And this is just taking the figures that I've been able to get hold of. And the production from Ikati, Diavik, Gachakuri, Snap Lake, Reynolds, and Victor, it's over $35 billion in a relatively short space of time, because those first mines, or the first pipes, found in 1980, coming into production in 1998. But a lot of them coming to the end of their life now. So unless they find something new, Canada is not going to be producing for that much longer. Australia, you've got Argyle, and it's about 12 hectares in size. It was found in 1979, came into production in 1985 and went underground in 2013. Also a massive grade, but low quality diamonds. The open pit had a grade of 680 carats per 680 carats per 100 tons, I think it was. But the dollar per carat was very low. But in total, they probably have produced maybe $6 billion worth of diamonds. And the open pit was in production for about 30 years. Underground was in production for not very long. And Argyle was a problematic mine for Rio Tinto. I think the open pit went well, underground not so long. Madurai in Tanzania, massive ore body, massive pipe, 146 hectares, found in 1940. Went dollar per carat values are quite high. The last one that I saw was about $369 a carat, and they produced in excess of $6 billion worth of diamonds, and they've been in production for a long time. It was an open pit. It was closed, I think, and on care and maintenance. I think it's looking at starting again. Its thing, I think, is well worthwhile mentioning. I don't know what the total production of that has been. But yeah, worldwide, you've got 17 mines. And that's why I come back to saying that if you look at all the mines in the world, the really big mines, there's 30 kimberlite pipes that have been producing for a long time, had a major effect on the areas, regions, and countries often in which they operated. These are just some photographs of the various pipes. This is the Rapa. You can see they've got two lobes as you go down, and you can see that now in the open pit. And this is the Ikati mine in Canada, open pit followed by underground mining operations. At Gachakuri, it's owned 51%, I think, by De Beers, 49% by Mountain Province, operated by Mountain Province. This is Katoka, very nice mine in Angola. It's operated by Alrosa and Diamant are the two big shareholders. This is Argyle. As I said earlier on, as an open pit, it worked well. It was a good mining operation. It produced some of these beautiful diamonds, the pinks and even a few blues, but underground was very problematic. The open pit produced on average, about 9 million tons a year. When they went underground, the intention was to keep production at that same level, 9 million tons a year. They never got it much above 6.5 million tons from underground. And the original estimate of what it would cost them to bring the underground into production was just over $400 million US. They eventually spent over 2 billion. I think the final cost was about 2.2 billion on the underground mine, and it never, I doubt whether they got their money back. And this is what it looked like. So they had the open pit up there. They came underneath that with a block cave. And then on paper, they had sublevel caving. So there's considerable ore still in the ground, but I don't think anybody will have the risk appetite to go down there and do it. It was very difficult mining conditions. And this is, as I said earlier on, probably the biggest diamond pipe that's ever been found, most valuable certainly. And this is Dwanang mine planning to go underground, just looking at some of the costs and what they intend to do. So what you have after cut 9, or maybe even a bit deeper than that, they've got 3 pipes. They've got the center pipe, south pipe, and the north pipe. So in total, you'll have 149 million tons of ore. The average grade 127 million carats, with an average grade of 85 carats per 100 tons. The depth of mining will go down to about 1,000 meters. And this is just some of the costs associated with that. So the tonnage that they have available from the 3 pipes underground is about 130 million tons. The waste, will have to mine some waste. They intend to recover 105 million carats. The mine grade, depends on what you do, 90 carats per 100 tons. The average diamond price, $175 a carat. So your average revenue per ton treated, $170 per ton is the revenue that you get, and turn that into Pula, close to 1,700. And the total revenue, this is in Botswana Pula, will be about 200 billion Pula. The costs, and this is with going underground, obviously, the operating cost is about 36 billion to mine that. The operating cost per ton is about $300 a ton. The capital associated with that, 36 billion, and your stay in business capital about 5 billion. And again, just looking at what happens in practice, you've got the open pit, which was in production for about 50 years, area underneath that line, and then you've got for the open pit, and then what the value of the ore that you have underneath the line here. So the value in that open pit was 107 billion, more or less. The underground is worth about 19 billion. As I said earlier on, this is capex. This is what it cost you. To go underground, the capital expenditure will be around 3.6 billion US dollars. And your operating cost will be about $4.1 billion. So those are just some very, the order of a magnitude, not exact figures, but order of magnitude, which I hope are pretty close to what Dwanang is worth and what it's going to cost to go underground. A lot of money. And these are just some of my own observations and some of the risks that I see coming along. Kimberlite pipes have been relatively easy to find once the target area has been defined. So in the Kimberley area between 1869 and 1891, they found a lot of the mines. They found Bultfontein, Du Toitspan, Kimberley, De Beers, Wesselton, and some mines that were further out, like Koffiefontein and Jagersfontein. In Yakutia, once they were in the target area, up there in Yakutia, between 1955 and 1958, they found a lot of the major mines and kimberlite provinces, Marni, Udafni, Icon, in Botswana. In a relatively short time, once they found Arapa, Gavin Lamont and Jim Gibson, Manfred Marks, they found the other 55, I think it was, pipes in that province. They found them relatively quickly. Dr. Lamont moved down to Lobatse, and again, in a very short space of time, they found Jwaneng, and I think there's 13 pipes in the Jwaneng cluster. In Canada, again, once they were in the right areas, once they knew what they were looking for and how to do it, it didn't take them too long to find Equati and Diavec. They've been very efficient. The prospectors, and they're getting better. But all that I'm trying to get at here is you've probably got a fairly low probability of finding a new kimberlite province. People know where the kimberlite should be. And it's certainly not impossible to find another mine like Jwaneng. I certainly hope that they do find, but I think the probability of finding a new kimberlite province is probably not so good. And the other thing that I have here is going underground is an extensive and complex process involving technical, financial, and implementation risk. Both Jwaneng and Venetia have been continuously evaluating a transition from the open pit to underground for 20 years. And Jwaneng continues to do that quite sensibly. They've got to keep looking. You've got to evaluate the risk, evaluate the cost, what's in the ground. As I mentioned earlier on, Argyle going underground cost far more than planned, and it never achieved its planned production from underground. And I don't think it made Rio Tinto money from underground. International, the Russian operation, small one, took 19 years to transition from that open pit to the underground. Permafrost, gas, oil, you name it, they had the problems. And this is just a general look at some of the risks associated with implementing projects. And this is mining projects. This is work that was done when we were looking at taking Cullinan underground with the CCAT. So what this table says, starting right here at the bottom, how many projects come in on budget? And you can see the figure here, about say 53, 54 come in on budget. If you look at how many come in on time, about 45% come in on time. If you're looking at both time and budget, 25%. If you look at some that come in a bit better than what they predicted and come in, it's 15%. If you're looking at predictable, fast and low cost, less than 10%. They work as expected. In other words, in terms of what you expect them to produce, you're looking at maybe 7 or 8%. And then if you bring safety into it as well, very few mines. So it's a technical challenge for anybody to go underground. And I think mining people are very well aware of that, especially the people who have to supply the funds from the big mining companies. And this is just a little bit of an overview. If you do what you should do, come with the conceptual studies, the pre-feasibility and feasibility, and you do good planning, and you do good execution, you're probably going to have a good project. If you don't go through those phases, and these days very few mining projects seem to go through all those phases, you end up down on the low road down here. So you might have good execution or poor execution, but yeah, the poor project manager, he's under tremendous stress all the time. Probably doesn't last that long. They come and go quite rapidly. And I'm not going to go into this in any detail. It's just looking at some of the additional risks that you have. This is common to all mines. I think something that is becoming increasingly important is the license to operate. If you can't satisfy the country and the people, the chances of you getting to mine are pretty small. And that's it from me. Thank you.
That the Alrosa website has got a lot of very good information. I mean, you know, they do quite regular investor reports in PowerPoint format, and there's fantastic information in there. And they also publish annual sort of management reviews, going into quite a bit of detail on their operations, including grades and, surprisingly at times, diamond prices for the individual operations.
Thanks, Paul.
Worth a look.
Thanks, well, I'll have a look at that because I did struggle to really come up with something that I could say.
I was
exactly
actually,
how much those guys
I
are
was
doing.
amazed at the amount of detail that was on there. And I'll send you a couple of I'll send you a couple of examples, but you know, you control that website for days, I tell you.
Oh, thank you. Thank you.
Yeah, but I mean, they're effectively a public company, so to speak.
Yes.
It's a very good website. Yeah,
Yeah.
yeah, it's
Now,
been amazing.
Archangel Diamonds, for instance, is completely the opposite.
Yeah.
It's very difficult to find information.
Okay, there's a question in the chat box, Pat, if you can have a look, or we can read it to you about why some of the reasons mines would change their method.
Well, I think if you look at it, obviously you change from an open pit to underground because it's just becoming prohibitively expensive. Your stripping ratio becomes more and more, and you're moving a lot of tons to get a ton out of the open pit. So eventually it becomes cheaper to go underground. You've got to consider risk as well. And then when you go underground, I think most mines have chosen to go with block caving because block caving is not that expensive. It's technically quite difficult. You have to put a lot of your money up front. Obviously, you're spending maybe for 5-6 years ahead of getting any production out. And then as you go deeper, a lot of mines have transitioned to something like sub-level caving. And normally that is because your ore becomes more competent and the ore body is not big enough to allow caving. So it's really an assessment of the shape of the pipe and what you can get out of it that makes you change your mining method. There have been some others where I don't really know what the logic was behind vertical crater retreat. I think the only reason that I could ever find why Bultfontein went to vertical crater retreat was because they had a mine manager who came from Prisca, where they'd implemented vertical crater retreats on the copper mines there. And he thought it might work, so he implemented it. And also with the open stopes, the massive open stopes at Cullinan, it was, when I got there in 1983, all the mining guys said, well, they never thought that these open stopes would work, but the planning guys did, so they went ahead, they implemented it, but it didn't work, probably because people weren't that dedicated to making it work, and they just referred it back to block caving. So sometimes it's good technical reasons, and sometimes it's really just, I don't know, differential engineering or something.
Yeah, I think sometimes it's the boss. You get these big mining characters, Pat, who did it their way and impose their methods on. I mean, you can probably name some of them, and I presume that's why engineers are always behind schedule and over budget. Particularly in these big mining companies where you have so much redundancy built in, and they just keep spending money. Geologists can budget, I would think, Bill.
Yeah, but I think, to be fair to the mining engineers, if you're now stepping back, to the late 1940s and so on, reopening all these underground mines. No one in Southern Africa had done anything like that before, to the best of my knowledge. So, as Pat said, they were, going all over the world trying to find new methodologies and things that would work for them. So there's been a lot of learning, I think, in the last 60, 70 years. And, mining today, I think, is very different to what it is now. And it's the same in exploration and all these things that we're busy with. The way things are today is not the way they were at that time. And people had to make, they were making risk decisions based on, you have to believe the best information that they had at the time. And yes, at times it would have been, a bit of a bet on this and let's see what happens type of thing.
Well, I agree with you. I think that these days the mining engineers are very professional at what they do. And when when the unexpected happens, they've got to deal with the situation, and that's often the problem. It's just they didn't anticipate. Like Argyle, the one thing that happened to them was they knew that it was going to, that eventually they would cave through to the open pit. What they hadn't anticipated was that there was going to be massive rainfall. So they ended up with the pit flooding, and at that time they were in the process, or they were almost ready to cave through. So for 9 months they could do nothing. And things like that are very often what catches you. You just you can't anticipate everything. You can look at the risk and you can do what and they're good at it. I think a lot of the mining engineers are very professional.
I think, Pat, one of the big successes was the Premier project going under the sill, with the caving of the sill, which was, you know, I mean, people faced that with trepidation in the 1970s when they were looking at it, 60s and 70s.
Well, they did. And there was a lot of study on that done, but eventually it was the guys on the mine that said, well, we think we know what to do. And they just went ahead and they did it. And it worked pretty well. It kept the mine going for a long time. Obviously not perfectly. They learned a lot. But I think the going under the sill was successful. It's kept that mine going.
It's been an amazing mine, Pat. And just for interest, Jean Honey and his team at Akapa Mining are doing a great job on, I don't know what the correct word is, Andrea, maybe you can comment on, you know, scavenging and mining around the old joint shaft. So there's actually, you know, quite a lot of ore coming out of the joint shaft, surprisingly. And that all gets, you know, they also still mining or reprocessing the tailings, and John and his team are absolute masters at running pans, rotary pans, which are, you know, as you know, extremely inexpensive to run. So you know, Kimberley too is you know, really ticking along, and if the prices that we're seeing sort of, you know, maintain themselves, you know, other sort of older operations or small operations, I guess, will keep going for longer.
Yes, I think there's people are getting, certainly with the diamond price going where it is, you're going to get a lot of people coming back into the diamond business, mining, alluvials and small mining operations. They will, and a lot of the old operations, people, like you say, in Kimberley, they'll go back in and they do. There's other mines like Campus Dam. People have looked at that time and time again and never actually gone to it, but it's a fairly substantial open pit.
I think the problem there, it's been overrun by the community, you know, by the communities and informal housing.
It has. So,
yeah, and Andrew just reminds us, Wesselton too is also still producing.
I'm glad to hear that. I'm glad that they do.
Thanks, Pat. That was a lovely overview, and really appreciate it. It just goes to show, you know, and I guess, I had a question, just a road header. Maybe you just want to quickly explain before we end what a road header is. You know, these big things that chomp up the roads when they're retarring them, that the Russians use so regularly.
Well, it's almost like that. They use it for developing tunnels. So the Lesotho Highlands water scheme was developed using a road header. It's really just a big cutting head that they go in and they cut the rock with it. And it just advances slowly, maybe 5 meters a day in a tunnel, and that material comes out and they take it out. It's an expensive way to mine, but if you, in a mine like International or Marne or Eichel, where the value of ore in the ground is huge, you can afford a mining cost per ton of $300-400 a ton. It still makes you good money.
Yeah,
Thanks,
John.
Pat.
Sorry, John. I must just quickly say that the machines we used in Lesotho were known as tunnel boring machines, not quite a road header. A road header is almost like a tractor on, a back actor with a long boom, and on the front there's this rotating head that cuts the rock.
Oh, you're right. You're right. The road headers that they use, They even used one for a while at Cullinan to put in the tunnel development, are a lot different to what they used on the Lesotho Highland Water Project. Which is the same sort of technology to an extent.
Correct.